Movies make it look like sprinkler water comes out crystal clear, perfectly clean water pouring down the moment a sprinkler activates. But in real life, that's not always what happens. Sometimes initial water discharge of a sprinkler can be brown, black, or a nasty mix of both. So why does that happen? First, this doesn't mean every sprinkler system has dirty water. Some systems are maintained extremely well and may discharge relatively clear water. But many systems have water sitting inside pipes for years. And over time, things start happening inside those pipes. Fire sprinkler systems aren't constantly moving water like your sink or shower. In many systems, the water can sit inside the pipes for long periods of time. Over time, corrosion can occur. Rust particles can form. Sediment can build up. Biofilm and debris may develop. Some systems can even experience microbiologically influenced corrosion, also called MIC. As material builds up inside the piping, the first water discharge can carry those particles with it. This can also cause a bad smell. Have you ever seen someone do a repair in a commercial building, and once they open a piece of pipe, remove a fitting, open an outlet, or replace a sprinkler, that bad smell comes out? That's because fire sprinkler water isn't fresh moving water. It can sit inside steel piping for long periods of time, mixing with rust, corrosion byproducts, sediment, and sometimes biological growth. That's why the first water out of a sprinkler system can smell dirty, metallic, musty, or even rotten. Sprinkler water should never be treated like clean water. Avoid contact when possible and let qualified professionals handle system draining, testing, or flushing. So why brown and why black? Brown water is commonly associated with rust and iron particles. Dark or black water can sometimes come from corrosion byproducts, scale buildup, stagnant water conditions, or biological growth inside the system. The exact appearance can vary depending on the pipe material, water quality, system age, and overall condition. Can this be prevented? People in the fire protection industry take several steps to help reduce these issues. Quick note, the visuals shown here are generic educational examples. They're not intended to represent any specific brand, manufacturer, model, or approved installation method. One of the biggest goals is reducing trapped oxygen. Oxygen can accelerate corrosion. During filling procedures, technicians often bleed air from the system. In many systems, the inspector's test connection is located near the most remote part of the system. Opening the inspector's test connection allows trapped air and water to move through the piping. Once the excess air is removed and water flow stabilizes, the valve can be closed. Some systems also use automatic air vents or air release devices. These are usually installed at high points in the sprinkler piping, where air naturally wants to collect. When the system is filled with water, trapped air rises to these areas. The air vent allows that air to escape, instead of staying trapped inside the pipe. This matters because trapped air can create oxygen pockets inside the system. And oxygen is one of the things that can speed up corrosion inside steel pipe. Less trapped air can mean less oxygen exposure. And that can help reduce the chances of corrosion, dirty water, and long-term pipe damage. Now, an air vent doesn't magically make a system perfect, but it can be one part of a good corrosion control strategy. Some systems use nitrogen instead of oxygen-rich air. Regular air contains oxygen, and oxygen can speed up corrosion inside steel piping. When oxygen mixes with moisture inside the pipe, rust and corrosion can form over time. Nitrogen helps reduce the oxygen inside the system, which can significantly slow down internal corrosion. This is common in dry pipe and pre-action systems. What about flushing the sprinkler system? Does that help? Yes, but only to a point. Flushing can remove dirty water, rust flakes, sludge, and loose debris inside the pipe. But it does not stop corrosion. It cleans out some of the mess, but if oxygen-rich water or trapped air stays in the system, corrosion can come back. Regular inspections and maintenance help identify corrosion problems before they become severe. Quarterly, annual, and 5-year inspections all play an important role in keeping a sprinkler system reliable. The 5-year inspection is especially important for catching internal corrosion, buildup, or hidden pipe issues that can lead to dirty brown or black water during system operation. Dirty sprinkler water doesn't automatically mean a sprinkler system is failing. And clear water doesn't necessarily mean a system is perfect. Every system condition is different. So next time you see crystal clear sprinkler water in a movie, just remember, real fire protection systems can tell a very different story. Follow Inside Fire Protection for more real fire protection breakdowns.